Welcome to ClickMyProject.com.
Now we can going to discuss about our product turbo message passing based receiver design for time varying OFDM systems. Next we can going to discuss about the abstract of our product, the proposed system implementation done for time varying orthogonal frequency division multiple access, that means OFDM system. This proposes the multi-join channels and signal estimation of the receiver. So we can is based on turbo message passing to the suppressed intercarrier noises. So we can implement it for additional things for factor graph representation on the formulation. We can using this whole signal direction and channel estimation also, and we have implement the two part of this system in OFDM. First part will be Gaussian message passing system for channel estimation, and the second thing we can using the discrete state space model for this employed transient signal states. These thing will be we can using the two hybrid algorithm. So we can forward and backward algorithm. We can using this of transient of signal. We can detect the some more difference of the signals in noises, and we have using the two different algorithm like discrete state space algorithm and continuous state space algorithm. So these two comparison we can making as the interference in channels, and we have channel estimate the error of the models, and we can suppress the carrier also. This finally the proposed system of this OFDM we can using the turbo message passing technique as make us efficient. Next we will discuss about the flow diagram of process. First we can see about the initialize the system parameter. The initialize system parameter nothing but we can initialize the system parameters, like we can using the subcarrier and the OFDM length. So these categories we can initialize the system parameters. So and we can categorize as transmit data. The transmit data is of OFDM signal will be speech signal or radio frequency signal, whatever we can giving the zeros and ones signals, binary signals we can passing the transmit data. The transmit data is passed to the channel model. The channel model we can interior part for the time varying continuous time channel model and a time varying discrete time channel model. This continuous time and discrete time model will be changing the only for time domain. This time domain we can save us for the channel estimation. So this total block will be channel model, and this channel model we can pass in the our modulation. We are using the modulation for the QM PPSK. So we can using the PSK modulation for this modulating these OFDM signals. So under these OFDM signals we are passing the message passing technique for that signal model. So these are very important step of the our process. Because of this message passing discrete state space model of the signal. So the state space we can say a discrete signal of this different segregate separate as different segregate the signals for a discontinuous signal model, and we can message passing technique for continuous state space model for continuously we can getting the signals, like we can channel model. So these two techniques are like signal model, and this is passed to the again demodulation. This demodulation we can on transmit data we can using on speech signal like hello. This hello signal we can convert to the binary codes. This binary codes change to the this channel model, and to modulation and the signal model again we can using demodulation. So this hello message we can passing this total overall of gain, and this is convert to the again the change over to the hello, but we have some error excess of error we can getting because of this is like noise and like impurities. If we can using the BR estimation, this BR analysis we can very important step of the our entire process. Because of this bit error rate we can find out the performance of the analysis, and we have in our system proposed the four different comparison results, like different analysis we can using discrete state space model and continuous state space model and a joint allocation model and joint allocation with a LOC model. So this comparison we can find out the system analysis. So next we can go into our running procedure. Next we can go into discuss about the running procedure of our product. the proposed system implementation done in MATLAB version 2015b, and we can created we can using for the MATLAB script, and the MATLAB script we are using the main.m. We can using the initialize the parameter, system model, time varying, discrete time OFDM, and factor graph representation, algorithm one for discrete state space model, and receiving signal model, and algorithm 2 for continuous state signal model. I will run that model for this main.m. Just click to run that model. It will be loading for the wait bar. Now it's loading. In MATLAB, so it will show the message for busy. Yeah, wait bar will be still loading now. So wait a moment to complete the wait bar. Our execution will be completed. Next, we can see about the results. First, we can see about the our this is like BR versus SNR estimation, and this is like coded BR estimate performance of a square root of 0 will be 0, a of square root 3 is 0. So this estimation of 6 performance comparison plot, and the red line will be perfect CSI, and the blue line will be discrete state signal of Gaussian message passing, and the pink line mark will be joint estimation, and this magneta line we can using the continuous state space message passing, and the green mark using the joint estimation of LASSO, and these are like upper mode part of this comparison, and this error also will be very high, and joint comparison without I, I, ICI suppressions. So this BR and SNR performance plot will be gradually decreased, but our results performance mainly focused for the discrete signal state for Gaussian message passing technique. So this we can consider this blue line, and compared to this pink line. This is existing ones of pink line, and we have proposed system for this discrete state space model for our signal state of Gaussian message passing technique. So this is performance plot of these comparisons, and the next thing we can see for our square root of a2 is 0.2 into 10 to the power of 3. So this is a little bit below to the our blue mark. Because of this error will be we can increasing for the 0.2 10 power 3 we can increasing, but we can comparison result much better than previous one, because of we are getting that additional values for that 0.21 into 10 to the power of 3. And another thing we can see for the 0.5 into 20 to the power of 3, similar as this graph will be goes to the our green line. So this error will be very less compared to these previous techniques. So this adapted to for the joint estimation for the LASSO technique. So it will be very reduced to the previous ones to again 0.2 into 10 to the power of 3 also. And another thing, this is like encoder for the D3. We are using the D3 will be dimensional of the our OFDM vectors, and we have using the previous technique like similar of a joint OFDM without ISC suppressions, and we can remove for the previous techniques for the joint estimation in paper number 14. We can remove that. So this performance plot will be plotted. And another thing, this is on our MSC performance estimation of the our channel, and we are using the 5 different channels for that, and these are like the 5 different ones are like comparison plot, and this yellow mark we can using the estimator with without and ISI suppressions, and the pink mark similar as we can plot as performance we can plotting the SNR versus MSC, and this corresponding values are stored in the our MATLAB workspace. So the workspace value we will plotted as MATLAB syntax as using plots, and the MATLAB code we can initialize model, we can everything will be created as MATLAB code for main.m. That's all. Thanks for watching.